This is Mrs. Appia with Lesson 12, Angles Associated with Parallel Lines. Student outcomes for this lesson. Students know that corresponding angles, alternate interior angles, and alternate exterior angles of parallel lines are equal. Students know that when these pairs of angles are equal, the lines are parallel. Students know that the corresponding angles of parallel lines are equal because of properties related to translation. Students know that alternate interior angles of parallel lines are equal because of properties related to rotation. Students present informal arguments to draw conclusions about angles formed when parallel lines are cut by a transversal. The essential question for this lesson is, name 3 angle relationships formed when parallel lines are cut by a transversal, and what is special about the pairs of angles. Pause the video and copy the essential question.
In the figure below, line 1 here is not parallel to line 2 here. M is a transversal. Use a protractor to measure angles 1 through 8, which, if any, are equal, and explain why. Use your transparency if needed. So I'm going to demonstrate using your protractor to measure your angles. You want to line up the vertex with the line on your protractor, and then you also want to make sure that this is level on 0 on the left and 0 on the right, and then double check to make sure this is lined up on the vertex. Then you're measuring the opening of the angles. Notice that there are 2 sets of numbers, 0, 10, 20, 30, and 180, 170, 160. So you want to start out with the numbers that are at 0 on that line. So here, 0 is the top set of numbers. So for measuring this angle, and I'm going to double check and make sure that that's lined up carefully. So here we have 10, 20, 30, 40, 50, 60, 70, 80, all the way to 110. Here's 115, 116, 117. So this angle is 117 degrees. While I have this lined up, I can also measure angle 2. Measure of angle 2, this is an acute angle, so it's going to be less than 90 degrees. So I'm measuring from this side, and this side, starting at 0, is on the inside of the protractor. So I've got 0, 10, 20, 30, 40, 50, 60, and then I'm going to go up here, 60, 61, 62, 63. So I have 63 degrees for this acute angle. Then I want you to notice that this is a straight line, and so these 2 angles are supplementary, meaning they will add up to 180 degrees. So that's a good way to check and make sure that you have measured accurately, is to add these numbers and make sure they add up to 180 degrees. Now notice also on my picture that I have extended these lines so that I could measure accurately and read my protractor. When you measure angle 3 and 4, you can either rotate your paper or you can rotate your protractor. So again, make sure that you line this up carefully with the vertex, make sure that it's level on both sides, and measure carefully. Go ahead and pause the video and measure the remaining angles. So you've had time to measure them. We've got 117 degrees for angle 3, 63 degrees for angle 4. Angle 5 is 104 degrees. Angle 6, 76 degrees. Angle 8, 76 degrees. And angle 7, 104 degrees. Which, if any, are equal in measure? So let's write a few things. We have several definitions to go through on this page. The first thing that I want to review is vertical angles. And remember, vertical angles are formed by intersecting lines. And we know that vertical angles are equal in measure. So let's go ahead and add that up here on your notes. Vertical angles are formed by intersecting lines. And are equal in measure. Which, if any, are equal. So we know that the measure of angle 1 is equal to the measure of angle 3. Let's add that over here. The measure of angle 1 is equal to the measure of angle 3. And then the measure of angle 2 and the measure of angle 4 are both 63 degrees. So you have the measure of angle 2 equal to the measure of angle 4. We have the measure of angle 5 equal to the measure of angle 7. Those are vertical angles. And then we also have another pair. The measure of angle 6 is equal to the measure of angle 8. The question is also being asked, explain why. So taking a look at why the angles are equal, let's look at angle 1. Angle 1 right here is 117 degrees. And if we rotate around that vertex, we see that it is equal to angle 3. And we know that when you perform a rotation, the angle measures are preserved, proving that angle 1 and angle 3 are congruent. And similarly, you can prove that for angle 2 and angle 4. Then let's take a look at angle 5 below. For angle 5, here's our angle, and if we perform a rotation around the vertex, we see that it is congruent to angle 7, 104 degrees. Similarly, we can prove that with angle 6. Here is angle 6 at 76 degrees. We'll perform a rotation, 180 degrees, and the angle measure is preserved. So let's take a look at another set of angles. Let's talk about alternate interior pairs. Add this to your notes. Alternate interior angles. These are angles that are inside the two lines, line 1 and line 2, and they alternate sides of the transversal. So our alternate interior angles are angle 4 and angle 6. They are inside the lines and alternate the sides of the transversal. One is on the left and one is on the right. So one pair is angle 4 and angle 6. The other pair of alternate interiors are angle 3 and angle 5. Angle 3 and angle 5. Those are alternate interior angles. Another type of angle that we know about are called alternate exterior. Add that to your notes. Alternate exterior angles. And alternate exteriors, they are on the outside of the two lines. Alternating sides of the transversal. Alternate exterior angles. So these are our two lines. The exterior ones are 1 and 2 and 7 and 8. They are outside of the lines. And then alternate exterior, one would be on the left and one would be on the right. So the alternate exterior pairs in this example are angle 1 and angle 7. Outside, left, and right. So angle 1 and angle 7. And then the other pair, that would be angle 2 and angle 8. Next, we have corresponding angles. So let's add that to your notes down here. Corresponding angles they're in the same position relative to the two lines and transversal. Corresponding angles. They are in the same position relative to the two lines and the transversal. So our first pair of corresponding angles. So in terms of the two lines, we can say it's on top of the line and on top of the line. So angle 1 and angle 5. And then the same position in the terms of the transversal would be on the left side. So angle 1 and angle 5 are corresponding because they are both on top of the lines and to the left of the transversal. So we have angle 1 and angle 5 are a corresponding pair. The next pair of corresponding, so let's do on the right side of the transversal and over the lines. So here's our line, so we have angle 2 and angle 6 being on top of the lines and on the right side. So our next pair is angle 2 and angle 6. Next, let's look at under the lines. Under the lines and on the left are angle 4 and angle 8. Angle 4 and angle 8. They are both below the lines and on the left side. And then our last pair would be below and on the right. So angle 3 is below and angle 7 is below, and they are both on the right side. So we have angle 3 and angle 7. These are called corresponding angles. In Exploratory Challenge 2, in the figure below, lines 1 is parallel to line 2, and M is a transversal. Use a protractor to measure angles 1 through 8. List the angles that are equal in measure. So remember to extend the length of each line and then measure with a protractor. Pause the video and measure all of your angles, and then resume the video when you are ready to check your work. Angle 1, the measure is 39 degrees. Angle 2, 141 degrees. Angle 4, 141 degrees. Angle 3, 39 degrees. Angle 5, 39 degrees. Angle 6, 141 degrees. Angle 7, 39 degrees. And angle 8, 141 degrees. The angles that are equal in measure. The measure of angle 1 is equal to the measure of angle 3, which is equal to the measure of angle 5, which is equal to the measure of angle 7. Other pairs of congruent angles. The measure of angle 2 is equal to the measure of angle 4, which is equal to the measure of angle 6, which is equal to the measure of angle 8. Question A. What did you notice about the measures of angle 1 and angle 5? Why do you think this is so? Pause the video to look at the measures of those angles and then see if you can come up with a reason of why. So we know that the measure of angle 1 is equal to the measure of angle 5. We can translate angle 1 along a vector along line M. So if we make a vertex here and we call that A, and we make this vertex point B, and we translate along this vector AB, then we can translate this angle, angle 1. So I'm going to go ahead and do that. Here is my angle. The vector that I'm translating along is here. So I'm going to move point A to point B, translating along that vector. And then I see that when I map angle 1 onto angle 5, that it is the same angle. So I translate angle 1 along vector AB. So the vertex of angle 1 maps onto the vertex of angle 5. Remember that translations preserve angle measure. So the two angles coincide. Question B. What do you notice about the measure of angle 3 and angle 7? So here is angle 3 and here is angle 7. What do you notice and why do you think this is so? Use a transparency. And are there any other pairs of angles with the same relationship? Pause the video, explore, and write your answer. Then resume the video when you are ready. So we see that angle 3 and angle 7 have the same measure. We can translate angle 3 along the same vector, AB. And when we translate along that vector, remember that when you translate an angle, the shape is preserved, the angle measure is preserved. So the measure of angle 3 is equal to the measure of angle 7. The measure of angle 3 is equal to the measure of angle 7 for the same reason as the previous problem. We can translate angle 1, or rather angle 3, along vector AB onto angle 7. And we know that translations preserve angle measure, so the two angles coincide. Translations preserve angle measure. Are there any other pairs of angles with this same relationship? If so, explain. We see that the measure of angle 4 and angle 8 would have the same relationship. Remember that these are corresponding angles, and corresponding angles, here we see corresponding angles in parallel lines are equal in measure, because we can translate angle A onto angle 8. We can translate angle 4 onto angle 8. And if you can map one angle onto another, that proves congruence. So we have the measure of angle 4 equal to the measure of angle 8. And we also know that that has the same measure as angle 2 and angle 6. The measure of angle 2 and the measure of angle 6. And we proved that those have the same measure because they are vertical angles, and you can rotate one onto the other, proving that they have the same measure. One last thing that I wanted to point out. If we take a midpoint between these two vertices, let's take a midpoint there, and let's do a 180-degree rotation with angle 3. So angle 3 is right here, and actually I want to rotate the whole set of angles. Let's get that right on there. So I'm going to go ahead and I'm going to draw that line and the transversal, and I'm going to rotate that 180 degrees. And remember, when we rotate 180 degrees, we end up with a parallel line. And so that is showing that the angles that we had in the upper quadrant are the same as the angles that we have in the lower quadrant here. And we did that with a 180-degree rotation, because we know that a 180-degree rotation will result in corresponding parts being parallel to each other and congruent. So what do you notice about angles 4 and angle 6, and why do you think this is so? Angle 4 and angle 6. We have angle 4 right here and angle 6 right here. So what do you notice, and why do you think that is so? Pause the video and explore that. Alright, so let's take a look at that. And as I just did that last rotation, I'm going to go ahead and look at that one more time. So here's angle 4 right here, and I want to explore this angle compared to this angle. So I'm going to go ahead and do that rotation of 180 degrees one more time. So I just did a 180-degree rotation, and that rotation moved angle 4 into the position of angle 6. So if you can map one angle onto another, that proves that they are equal. And the 180-degree rotation, then we have this segment parallel to this segment. So line L parallel to line 2, or line 1 parallel to line 2. So what do we notice about the measures of angle 4 and angle 6? The measure of angle 4 is equal to the measure of angle 6. We know this because we did a 180-degree rotation. Around point M. And we know that a rotation results in congruent angles because angle measures are preserved. Then what's the relationship between angle 4 and angle 6? Angle 4 and angle 6 are both interior angles, and they are on alternating sides of the transversal. So angle 4 and angle 6 are called alternate interior angles. Okay, turn your page.
If you know that pairs of corresponding angles, alternate interior angles, and alternate exterior angles are congruent, what do you think is true about the lines? The lines are parallel. So here is the theorem of what we have learned with our parallel lines and our transversal. When parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. The pairs of alternate interior angles are congruent, and the pairs of alternate exterior angles are congruent. In this theorem, we have answered the essential question for today. The converse of the theorem. When alternate interior angles are congruent, then the lines cut by a transversal are parallel. When alternate exterior angles are congruent, then the lines cut by a transversal are parallel. When corresponding angles are congruent, then the lines cut by a transversal are parallel. Pause the video and copy this information. So let's summarize what we have learned. We've got our figure here and we have two lines. Angles that are on the same side of the transversal in corresponding positions. In other words, above each of line 1 and line 2, or below each of line 1 and line 2, are called corresponding angles. For example, angle 2 and angle 4 are corresponding angles. So here we have line 1 and line 2, and it is cut by the transversal M. The corresponding angles are in the same position regarding these two lines and the transversal. So here, angle 2 and angle 4. Angle 2 is below the line, angle 4 is below the line, and they are both on the left side of the transversal. Other corresponding angles are angle 1 and angle 3, angle 8 and angle 6, angle 7 and angle 5. Corresponding angles are in the same position relative to the two lines and the transversal. Next, alternate interior. When angles are opposite sides of the transversal, in other words, on the left and on the right, between or inside the lines, line 1 and line 2, they are called alternate interior angles. For example, angle 3 and angle 7 are alternate interior angles. Angle 3 is inside, angle 7 is inside, so they are inside the two lines. One is on the right and the other is on the left. They are alternate interior. The other pair of alternate interior is angle 2 paired up with angle 6. Then we learned about alternate exterior. Angles are on the opposite side of the transversal, so left and right, and above and below, so outside of the lines. They are called alternate exterior. For example, angle 1 and angle 5. Angle 1 is outside of the line. Angle 5 is outside of the line. So these are the inside angles, and these are the outside angles. So exterior would be 1 and 5. Those are alternating exterior because they are exterior and they alternate sides of the transversal. One is on the left, the other is on the right. The other pair of alternate exterior angles. The other pair is angle 1 paired up with angle 8 paired up with angle 4. We know that when parallel lines are cut by a transversal, any corresponding angles, any alternate interior angles, and any alternate exterior angles are equal in measure. If the lines are not parallel, then the angles are not equal in measure. And that concludes the lesson.